Hello everyone. Welcome to Krhom Live, where we usually repair electronics, but today we're repairing something else. Big spoiler, it's in the title. Uh, we are going to be looking at LiPos. Do I have anything to update from last week? I don't think so. We were looking into goggles, fat shark goggles. I had a bunch of discussions with some people I know who know more about this than I do. And the way I was going about it wasn't too bad. Trying to feed the video signal directly to the main board, kind of confirm that something's broken on that main board. So it's the DVR board. You can supposedly buy those separately, but they are quite expensive. I could only find it on eBay for like $150, so or 99, something like that. But so I'm not going to go that way. But at some point, I'll pull out the board and see if I can understand a bit more how it works. See if there's something very obviously broken. I'll keep trying to inject some video signals into it. See if I can track down where it's going bad and what's happening with it. So it's not a priority at the moment. I'll revisit it probably on my own time. If I find something interesting, I'll bring it to the stream and show you guys. So today we're doing this. This is a bad safe box. It's a box dedicated to containing LiPos and to contain the smoke and the flames mostly if they go bad. And the reason I have it here because we're going to work on LiPos, and if I don't do it correctly on stream, everybody's going to shout at me that I'm not taking all safety precautions. So I'll do it right. In this, we have some LiPos. They're actually my flight pack, and I'm kind of cheating you today because I'm going on holiday for 2 weeks, and I need to repair those for myself. So I'm bringing you along. So what's happening is, I can show you those LiPos. They all have a dead cell. So this one is cell 1. Cell 4 is also tired. Cell 6 is also tired. So this one is really not good, looking great. And all of them have some kind of dead or dying cell. So this one, and you could think it's like, oh yeah, it's just a slightly tired cell, you know, it's fine, you can still fly it. That's true, but because it's so imbalanced, it takes forever to charge. And when I fly it, because the cell is damaged and sagged so much, I get 2 minutes of flight before it starts complaining about voltage, which, I mean, you can see there's still like a bunch of charge left in those packs. I haven't storaged it, but there's a bunch more flight time on there, and I couldn't really get to it without completely killing the cell 3. So I need to swap out cell 6. And what's going to happen is I'm going to choose one of them, and it's going to give away its good cells to all the ones that have a dead cell. So yeah. Yeah, this one's just 5S. No, it is not a 5S, but it's showing as a 5S. So I don't know exactly which one I'm gonna take to save the other ones, also a 5S. So by the way, those tattoos, they're absolutely amazing when they're new. They fly amazing. But I had 10 of them, and I have now 6 that I need to repair. And all of them have 1 dead cell or more. So yeah, fun while it lasted, very expensive. I mean, in the end, I'm gonna, oh, this one isn't one I want to swap. It's one that I need to repair the pigtail for, the balance lead for. So just so, I know some people are intimidated by those repairs, so I'll show it on stream. This one also had a weird accident where, I poked at it while I was unplugging my quad. I poked it with my finger, and it dug a hole in my finger. It burned, basically those contacted and sparked inside my finger. So fun. So this one's gonna come next. So what I'm gonna do here is I'm gonna keep that on the side. So if I get some kind of accident with LiPos, I can just put it in there, close it down, bring it outside. That won't happen, but I'll have it there just to the side, just in case. So we have a few people in chat. Hi, Groniatu, Min Dupro, Makshaki, Danza, Big. Min Dupro, you're asking if I'm French in real life. I'm French in every kind of life, but I have lived in the UK for a while. And I have more people, more French friends who speak English than English friends who speak French. So I chose to do the stream in English. That is why. But yes, I am French. You can kind of hear it in my accent, but I don't have the typical French accent because I have lived abroad for a while. Hey, We the Rider. Also today, because I'm not going to be doing something that's, well, I'm going to be doing the same thing a few times. I'm going to be looking at the chat a ton, and any question you have, any things you want to know about FPV, electronics, and stuff like that, you just have to ask, and I'll take the time to respond and try to explain if there's something a bit more involved. So yeah, we'll be doing that. So yeah, feel free to ask any question you want. I'll be there to answer. So I think I'll take the one that has two kind of bad cells and use the four other cells to repair the other LiPos. So if I look here, yeah, so it has one, yeah, so one of them is completely dead, and three of the, like the four there look decent, and the last one doesn't look so good. So I'll pick the middle four, and so we'll extract them, and I'll reuse them to save the packs, and we'll should be good. Yeah, Mads. Hey, Mads. Yeah, you also had the experience with burnt fingers. Mine really like dug a pretty decent hole in my finger, but I survived. It was quite painful because there's so many nerves at the end of the finger. So yeah, let's start opening it up. Obviously, like the way a LiPo is made isn't very complicated. It's just 6 batteries next to each other in series. That's what the S6S means, 6 in series. And they are just soldered together, and there's a wire for the balance lead that goes to each of them. There is some amount of care that needs to be used when opening them up, just because we don't want to go and actually, that's the one no, that's not one I already opened. We don't want to go and short stuff. If we short stuff, it will make sparks. And so you can see here, they have a side plate that's made, I think, of fiberglass, so similar to PCBs, but very thin. Sometimes they have, like this one has a metal cover, which I thought that was a metal plate, but no, it's just a metal corner. And I don't know if it's related to them losing cells on the outside. I feel like it's more likely due to shocks. But we want those 4 cells in the middle, so we'll be looking into removing that. So I'm going to remove them one by one, and they're glued in the middle. So what you can do to facilitate release, and you don't want to kind of start pulling too hard, or you're going to be pulling on a punch, is inject some IPA, iso alcohol, and take a thin pry tool, plastic pry tool, like those, for example, which I can get online. Just start gently prying. You can go faster if you just want to take stuff apart, but here I'm trying to, so this cell I don't care about, so I'm going to be kind of hard on it, but the other ones I want to keep, so we don't want to start damaging them. So I need to be gentle. So I want to remove it. I could desolder it now to some extent, but I want to be able to open it as like a butterfly before I can desolder it from the other. So those are soldered together with what's it called? Spot welding. So we won't be able to desolder the spot weld. So we're gonna have to cut some of the tabs on the batteries and then put some more solder on them. So here, I'll desolder this, the negative lead. So here, for example, if I were to use those pliers, I run the risk when I grab this cable of contacting this cell while also contacting the other one. Should be okay because the cell is dead. But what I can do to avoid the risk is use ceramic pliers. Those are non-conductive, so if I can't really short anything with them. Let's see if I can remove the whole cover first. There we go. More room to maneuver. Let's go for the big heat. It's not going to be leaded solder, so it takes a while to melt. And the anode is the anode or cathode or whichever it is copper, so it sucks the heat out quite a bit. I'll get it to melt though eventually. Don't have a good grip on it. There we go. That should come off anytime. Don't remember, I've already opened one of them. I don't remember it being that hard to desolder, as if I didn't have good contact with my iron. I'm going to add some leaded. So once again, I'm heating the pouch, but it's not an issue because I don't want to recover that one anyway. And it's completely dead. I think that's the one that's completely dead. I'm going to add some more, a bit of leaded, and it's going to lower the melting point. There you go, now it's being alloyed and should melt easy. Hopefully. There we go, it's coming. Hopefully we have a better time with the other ones. I'll add some leaded every time quickly. So I'm removing the balance lead, the balance wire, and now we can. So now we only have this. This cell is only attached by this tab. So let me remove this so it doesn't remove the other side just afterwards. And so yeah, you can see this is a free tab and this is welded to the other side. And since I don't care about keeping this side, I just want to go and cut. Let's find my cutting pliers. Where are they? Here. I can just go and cut the tab. So you can just, there we go. So that's one of the cells I don't care about, it's dead. Hey, Neo. So that's one, and they are quite deformed, but they should still do the job. I'm half thinking I should get. Yeah, no, they aren't. They're gonna be good. I'm gonna flatten them once I pull them out. So those I want to remove. Let me remove the one from the other side, and that way I can work on the four good ones easily. Let's remove this. So this time I'm gonna directly alloy it. I'm gonna go up in temp as well. Try to go fast. Yeah, it looks like it melts way better this side. Okay. There we go. Remove the bands as well. So this and this can probably. So you can see here they're putting a bunch of ice insulators under the tabs, which is quite nice. Reduces the chance of shorting. We can remove the lead, the balance lead on all of them. Should be easy enough to, shouldn't have too much thermal mass. So it should come off super quick. I hope, yeah. I'll remove them as I go. So let's separate this outer dead cell. Just be careful. Hey, Romain. Yeah, it shouldn't explode. There's no reason it would. I've done this a few times. I haven't done it to that scale, but okay. So this one also I can remove by cutting the tab here. The other ones, since I want to use them, I won't be able to just cut the tabs easily. I'm gonna have to split the tab in two so it can be reused. Right. Let's start separating the good ones, so the bad ones go in the box. Let's separate. Gonna keep it separated. So I'm gonna do my best to separate them without deforming them too much or pulling too much, just because I want to keep them in as good a shape as possible. Oh, it looks like the middle ones might not be stuck as well. Oh no, it's just the sticker is at the bottom. Okay. Let's apply IPA and pull slowly and let it come apart. There we go, easy. That one went well. So we want to remove that cell, but we want to, so we have one tab here, which is fine. I'm gonna pull pull the balance out. And I'll want to basically find a way to split it from its friend, but keep some amount of tab on both sides. I mean, if I don't, it's not the end of the world. If I lose a cell, it's not the end of the world. I can just have many donors, possibly. There's 6 cells or 5 cells per LiPo, but I'd rather repair them than use them as donors. So, here is the tab. Yeah, that's this tab here. And this tab, I can unfold it. You can see has this side that's part of this cell, and the other side that's part of the other cell, and they are welded. So if I cut it next to here, I should have enough of both. So here, I just need to be super careful not to short anything with my pliers. That's where we could see spark today. But yeah, so that's one of the good cells. I'm going to flatten it out. I'll keep the rubber things, see if I can get, and the filler foam, I'll see if I can get them back in place. I'd like to press them, but they are sticky. So I'll try to remove the adhesive first, which looks like I can do with IPA, because I want to press them on the desk to make them flatter. That would be ideal. Try to put them back into shape. Hey, son. Oh, it's so slimy when you start applying IPA on glue like this. What I can do is just use a piece of sticker. Actually, I'm not going to take too much time trying to save them. I'm just going to wait for it till it evaporates. I'll put a bit of Kapton tape. Kapton tape is not going to change anything. Oh, my fingers are all sticky now. Using Kapton tape will not make this cell thicker by any remarkable margin. Oh, it's all, my hands are all sticky. So yeah, I'm just going to put some. You don't want to put any tape that's going to add significant thickness to the battery, to the pouch, because otherwise it's going to make it fitting it in the LiPo harder. But you can do this. Okay, and now I can do the same for the other side. And now I can push it flat. So what do I have that will push it flat well? Do I have something flat and heavy? Let me look around. Good. Why don't I have anything large and flat and heavy? I guess I can use this box. Seems flat enough. I'm not going to go too crazy with it. I just want to give it a bit of a squeeze down. There we go. It's a bit much flatter. All right. I'll just do this 3 more times, and we'll have our donors. And then we can look into cleaning up some of those. Actually, might as well clean it up now. This tab has the piece from the other one left. I'm gonna cut it. We can check that the cell is still good. I'll check the metal. Yeah, it's time to forge it. I'm not gonna hit it with a hammer though. Meter volts. please. Oh, I have a cable that's in front of my touchscreen that's pressing the buttons for me. Yes, so this should still measure 3.8. We're all good. And that's how I'm going to know which one is the positive as well. So here, the positive is this one, because when I put the red probe on it, I have a positive value, so 3.8. If I do it the other way around, it's going to be minus 3.8. If I do it correctly. Yeah. Let's continue. So how are you guys doing? Do you have big plans for the upcoming summer? Are you all going to go and fly across the world or something? Hey, Gregory. Welcome, welcome. We're taking a LiPo apart so we can use the cells to save other ones. That's when I should probably have some music on. So yeah, for those of you who, there's no reason everybody would have heard, but in a couple of weeks, we are doing, and when I say we, I mean my team called Bundle Lovers. We are doing an event, a bundle race event that's going to be on Twitch, live on Twitch, where we have like about 40 to 50 pilots flying, racing inside of a bundle. And it's going to be live on our Twitch channel, Bundle Lovers. And you're welcome to join and watch, obviously. And it's going to be a ton of fun. So that's what I'm leaving, and there won't be streams for a while, for a couple of weeks at least, because I'm going on holiday, and then I'm going to that event, which isn't really a holiday, but is still going to be extremely a ton of fun. So here I want to keep as much of this tab as I can. So I'm going to come from the side and cut close. I'll see if I can insert my... There we go. So there's not a lot of tab left on this one, but it's going to be enough. Right, let's put this one to... Oops, it's pointy. Let's put this one to the side. I'll unstuck the other ones, and then I'll do the flattening. Yeah, pretty much, Gregory. There's two bad cells on this one, and I have a bunch of them that have one dead cell. So I'm doing some transplanting. And we keep going. I know I've been asked quite a bit to show it on stream, because a lot of people are very intimidated by LiPos, and bad cells is, in this case, they're just, so some of them are just dead, 0 volt. They don't appear at all in the meter, so a few volts at least, at tops. And some of them are just, they sag a lot. So we can actually do an IR check, and we can see if there's something visible in the internal resistance. But they sag a lot, and they gave me 2 minutes of flight because one of the cells is going super low, super fast. And it's not fun to fly. So they're getting the the repair. So because of the cells as deformed, I want to be super careful not putting too much stress. Here you can see on this one, you can see the marks from my pry tool a bit. It's nothing too bad, but I want to try to avoid doing it as much as I can. I don't want to pierce a pouch. It's not the end of the world if I do. Won't just catch on fire and burn. It will be mostly fine. But might as well avoid it. Okay, so this one has the tab looking. So yeah, I need to cut here the closest to as I can to the other one. I'll remove the balance lead quickly. My fingers are all sticky. It's very, very annoying. Yeah, Sanyo, the total voltage falls when they have a lot of difference. That's because while a few of the cells are still good, the one that's kind of broken goes down and goes to like 3 volts, and it stacks the whole pack. So that, ow, ah, shit, burned myself with a splatter of solder. Ah, fun times. I guess it's one more burn, you know. It's not the end of the world, but it's kind of surprising. Kind of. Don't see it coming. There we go. I did cut through. I left a bit of sleeve of metal. There we go. Oh. So need to desolder this one and desolder the other one, and then do the flattening. And then we'll do an IR check, and I'll show you a cool tool. These tweezers, yes, they are ceramic, so no conductivity, and I can just be a bit more careless with them. Ah, sticky, everything's sticky. It's annoying. There we go. Let's put some tape on them so I can flatten them without sticking them to my table. And then for the cells we're going to replace, we're going to be way more gentle. We'll try to open them up in a way that we can close them back more easily. By the way, where's my carbon plate? Huh, why did I don't know. There was a carbon plate on the pack, but must have put it somewhere. Let's see, yeah, now I'm curious to see whether we're going to see something in the internal resistance or not. And I hope I mean, those cells didn't look super healthy, but at the same time, they've been sitting for a while. So hopefully they're good enough to make it's fun to fly the packs, and if they're not, I can just always sort them again. Only takes time. There is some amount of like argument you can make about repairing LiPos that it's not worth the time, but those are really, really good. Like, and they are fairly expensive. So if you pay like high price for a LiPo and you can save it for maybe 20 or half an hour of time, 20 minutes, half an hour of time, I think it's worth it. Let's see if I can find something a bit less bendable for pushing down. No, I think it's going to have to be the same thing. It's going to have to be the box. Let's use the box. Let's remove all chances the tabs are going to short. Yeah, it's a bit better. It is a bit better. It's not the end all be all, but it's a bit better. All right, so I was saying, let me grab a tool. This is the tool. It's an internal resistance meter. So we'll be able to compare. So one of the two dead cells, well, the one I kind of say is dead. Let's see if they have any, if the dead one has any amount of voltage left. So let's go for normal measurement. So this one has literally nothing left, 0.06. So that's dead, but you can try to see if it measures any internal resistance. And the other one has 3.7. So let's see if the 3.7 one can measure. So I need to free up some amount of room on this tab so I can actually grab a measurement, because I did cut it super short, not thinking that I would want to have access to a bit of tab. It's gonna be hard. It's gonna be hard. We'll see. So let's see on a normal pouch what kind of measurement we get. Why do I get nothing? Because it was on hold. So yeah, that's 1.5 milliohms, and that's about par for the course for those batteries, so that's good. Let's check all the good ones, see if they are in the same range. Yeah, 1.58. So there's some amount of resistance due to contacts. But yeah, it settles down to about 1.55. Try the next one. And if we can't test the two ones I've removed, yeah, good. Then we'll see if we can, well, we'll try to test them. Yeah. I'm measuring wrong. I need to be at the end of the tab. Oh, maybe this one is not a good one to put on then. Can I see? It's a bit higher. It is a bit higher, and it is like, it looks like a small number, but it is maybe like 12 to 13% higher, which isn't great. Okay, so I'll use this one last, and let's see if we can get some amount of measurement on the dead ones. Yeah, but so that's the crazy 0-volt one, and you can see insane internal resistance 1/2 an ohm. So yeah, that's dead. And let's see if we can get some contact on the other one and check. Which brand do LiPo I usually fly? The ones I have the most of is Ovonic. I fly bandos, and in bandos the most important thing is value. So you want to find good bang for buck, because you're not going to be, they're not going to live very long. So and you're going to have to replace them. So you don't want to go and buy the stupid expensive tattoos like I did to test them. But I did, and yeah, they're really good, but they're not worth. I can't get a good contact on the probe on the other tab. That can, yeah, 5.8 milliohms instead of 1 and something. So yeah, definitely don't want to use that one. There you go. So those are definitely dead. We'll see the ones we remove. So yeah, in terms of LiPos, I have a bunch of them. I have had 10 tattoos. I had some Ovonics Rebel 150C, some Ovonics 160C, GNB, SMC. Just wanted to test stuff, but now I'm pretty much going back to Ovonic, as they don't last a ton, don't last very long. They get tired fairly quickly in my experience, but they are inexpensive, so you can just buy a new set every once in a while during sales, and they are quite cheap at the moment. So yeah, it's a good. Hey, Blue Black. So now we proceed. So we'll need to identify the ones we want to swap, so we don't mess it up, and then remove them. So we don't swap the wrong cell. Let's put this to the side for now. Let's clean stuff up a bit so you don't end up sorting all over. Did I throw? Oh yeah, I did throw my carbon plate in the bin when I. So those are carbon plates I cut to protect the LiPos. If you went into crash and go in bandos, do this. They can be cut with a big pair of scissors. They're annoying. Yeah, the GNB HV, generally people are kind of cautious about high volt because they tend to age faster. I don't have a ton of experience with the. I have 10 of the yellow ones, the super light 1500 mAh GNB ones for my 7-inch, and they're really good. They work really well, but I don't fly them as often enough to know if they age well or not. So I don't really know if they're worth if it's like whether you should go HV or not. But yeah, the GNB makes some good shit, and it's decently priced too. So especially if you go order from them, so it's nice. Let's grab our balance lead because we are saving that. And the rest can go to the bin. Okay, let's start with this guy. I'm super sad those are losing cells because they are really nice. And I might try to protect them better with a different carbon plate setup that prevents them from being squished, and see if that helps. But I'll do that on the next batch title, but since I'm not going to buy the next batch of those, I'll do that on the next batch of something, Ovonics maybe. We'll see. We'll see. So yeah, I'm about to, before, so we have this event in 2 weeks, but I'm going there earlier and hoping I'm going to have some time to fly at the spot. The spot is amazing. I want to see if I can get some time. Something tells me, I'm going to check, I'm going to double check, but something tells me this is the dead cell and not this. This looks perfect, flat and everything. This is all folded. So I'm pretty sure this is the dead cell, but we'll check. It should be the highest cell. So, so that would be cell 1 or cell, the one next to the positive. So maybe it's not. So it's cell 6. So is cell 6 the one next to the positive or not? Well, let's check. We can see that it's going to be between the cell that's deformed. It's going to be between positive and the next. So on the balance lead, it's going to be between the positive and the next. So I'm just going to check with the meter. Yeah, 0.3, 0.03. And if I check the other side, hopefully we get a healthy 3.8 to confirm that I'm not talking bullshit. It is. So it is the one that's deformed. Not surprising. Good. So what I'm going to do is make a cut here, open that side, remove the cell, swap it, and put a new one. Okay. So the best 3 cells here. So we need to make sure we don't cut the pouch itself. So I don't need to take a lot of precautions when removing this because, well, I'm not keeping that cell, it's dead. So now I want to cut this cleanly. I'll put back some tape. So I want to keep everything as clean and intact as possible, so I don't have to repair as much. Something, yeah, there we go. And below, same. Okay, so we have a bit of carton here. Cool. Okay, and I don't want to open it up more like this because I want to be able to close it back. So the difficulty here is going to be to join the cells, always is. And first we need to desolder this and the balance wire. So let's put that away. I'm going to start by, like I did before, adding a bunch of leaded. So it allows and lowers the melting point. Okay. Now we'll come in and desolder this. Went well. When you alloy it correctly, it does come off fairly easy. And then we need to remove the positive balance lead. Ouch, that's hot. I keep burning myself. The wire is hot. This is not a real burn, but it's still hot. I don't think it's a real burn. I hope it's not. Maybe it is. Ah, tonight is full of burns. It's funny, I'm repairing LiPos. Everybody's expecting a fire, and all you get is Me planning myself. You're flying GNB 2S every day. Yeah, they're really good, the 2S GNB, like the yellow ones, they're really good. And yeah, they seems to be holding okay, but I don't fly the Kayuminu very often, so I don't have any good element to get data to compare it to. I'm not going to put back this. There is some people who say it can pierce the cells. I don't know if it can. I mean, I'm sure it can. I don't know how common it is. So I'm not going to put it back. And I have the carbon plate on top that kind of protects this from digging into the cell anyway. But yeah, let's remove this. So to make sure it's not glued at the back, unglue it, just this one. There we go. And let's go again. Put that back. Okay. Okay, so the cells under it are kind of deformed, but we'll see if we can squeeze them back. So now, what I want to do to make my job easier is once again cut extremely close to the cell I want to remove. Let's try not to. So that's the dead cell. And let's see if we can squeeze this flat a bit. Box time. It's a bit flatter. It's going to be flat enough. All right. So now, the thing we need to not mess up is the polarity, because otherwise we end up with a 4S, weird 4S battery. Max Shaky, you're asking thoughts on hard packs for Bando. I don't think so. The first problem with hard packs is they are heavy, and you don't want heavy on your quad. Secondly, I don't think any kind of hard case is going to protect from the kind of shocks and crashes we get in bandos. So I would say it's probably there's probably a good reason we don't do it. Maybe I should grab one day, see. But can you find hard packs for the kind of LiPos we use, like 6S, 14, 1300? Not sure you can. I think they're kind of made for different things, so they don't really package them the same way. So here we know that this cell that's the plus, the positive, because we know this is the max voltage of the cell, so that's going to go to the positive of the new cell. So this negative of the new cell is going to go to here, which is positive. So we need to know which one here is positive and which one is negative. I'm guessing from the color this is going to be positive, but let's check. So if I measure this way, it should be positive on the... it's not. Okay, so that's the negative. Because now, if I put positive here, and I know why. It's because that's the part of the other. Yeah, it's the tab from the other cell. This one's the tab for the other cell that's welded, and that's the tab from this cell. I don't know. Okay, so it should go. Let me mark them, so I don't mess it up. So this is positive. This is negative. Why do I get no reading? And yeah, okay, so this is positive. So what we need to do is put some solder on this tab to be able to solder the big wire. And then put maybe, so what we're going to do for this one is it's going to fold over. So we're going to stick this under and fold over. So it would be good if we could tin some more. And the thing about tinning those is really, it's almost impossible if you don't have the right flux. And I'm pretty sure I haven't used it, but it's supposed to be the right flux. So we're going to be trying. Oh, let's go put some. We'll clean it up afterwards. So put some flux, take our solder wire, and it does work. Good. It is the right flux. It stinks a bit. It's a very different smell to the flux I'm used to, but it does the job very well. That's good. AliExpress didn't lie to me. And let's put some on. So that bottle cost me like €2, so that's pretty good. There we go. We have a good thing going. Now I want to put some solder here as well. Oh, I want it to go under. So I want to figure out exactly how. If I'm going over, that could work well. If I go over the tab, that could work well. And maybe I can just cut it a bit. I'd like to go under actually and kind of make a nice blob. So I need to cut it a bit. So I'll need to remove some of the solder I just added, trying to do that quickly without heating it up too much. Or remove it a bit. And I need to cut about half of it. Basically, I want to reach a point where I have it in place. I just need to flow some solder to get it clean, to get it cleanly soldered. So I'm going to cut a tiny bit of the tab. And this way, I should be able to insert it below here, like push it, and try to put it under the small, actually under nothing. I'm going to fold it on itself. I'll clean up the tip first. Clean up the flux first. Where's my tweezers? Trying to go, I haven't done it with that flux before, so I could go kind of dirty before, and I want to do it very clean this time, so I'm taking my time to set it up correctly. So here, I want the cell to be here, and it's going to be on top if I do that, and that's fine. So I just need to put on some flux here, and some solder along this, and some solder under. And that way, I'll be able to put it here, heat it up, well, let the solder melt together. So I'll do that. Because obviously I don't have what's it called? A spot welder, so I'm gonna have to do it that way. So here, I'm going to add some solder to the bottom of this. If I can get it to stick, seems like scratching the surface is doing it some good, so that's, I'll show you. Might have to put some more flux, but oftentimes when there's a layer of oxides, it's good to to scratch the surface with your iron. It's not easy. So let me show you what it looks like. So you can see it's all covered in solder at the bottom. I need to have some on top, so I'll clean that up with IPA. And now I need to put some solder on top of this here. So do the same thing. A bit of the flux, kind of spread it around. Yeah, so it's a flux special for binding to aluminium and other metals, and the normal flux is meant for copper. It doesn't really do the job that you need it to do. Oh, that's very nice. That's very pretty. I'm happy with that. Let's clean it up. Yeah, that's perfect. Now I just need to put this over and make sure this is going to touch. So I'm going to fold it back a bit. I put some regular flux here because now it's going to be solder versus solder, so I don't need any kind of special flux. So I can use regular flux. I'm going to put this on and I'm going to melt it all together. I want to make sure it's all contacting well. I think it is. Yep, I saw the solder flow. I think I'm going to check. It's not everywhere. It has a good contact point, but it's not everywhere. I think it's going to be good enough. What I'll do is add some more flux above. I want to not add a ton because I don't know how much you need to clean this flux. I'll try to add some solder. Yeah. That's being nicely flooded. Okay, we good? Now I just need to reattach the balance lead and the big wire, and we'll be good. Let's see if I can clean up this first with my alcohol. Yeah, this can go back over. We'll put on some Captain. Where's my Captain? Here. And then we'll be done and we can move on to the next one. Right, this can go. So I'm not gonna make the mistake of using my finger to hold the wire because I don't want to burn myself again for the third time today. And let's put on some flux, some regular flux at the interface. And let's solder this. And we're done. So there is I am going to put some Kapton over this. And we'll close it back up. So that wasn't so hard. That wasn't so bad. Was it? So we'll check now that it appears nicely and correctly as a 6s pack. Which it does. Yay, success. Now we close it back up. So, no, there are absolutely no electronics in the LiPo. No, it's just cells. The electronics is outside. That's your charger. That's what the BMS is. Your charger is the BMS. What tape? What tape? I'll use a bit of acetate. Use a bit. I don't have this tape. I don't have any of that, so I'm going to use some acetate. And I love acetate tape. It's like has this. It's super sticky and stays sticky and has the backing for that reason. And it's nice. Nice looking. Trying to put some amount of pressure on it. And that was not nearly long enough, but it will be good enough. It's going to be held by heat shrink anyway. And then here, put some, I guess I'll use some Kapton. I don't want to use too much heavy tape. No real reason to make the LiPo heavier. And it's all going to be held anyway by the heat shrink. So I'm just going to close it. Right. Oh, you can see I messed up by putting the balance wire the wrong location. It's not the end of the world, but let's see if I can shimmy it inside. There you go. Right. It's a bit better. It's not the end of the world, but I'll have to try to be careful to route it correctly next LiPo. So then let's finish this one completely, consider it repaired. So for that, we need to put the carbon plate and the heat shrink. My heat shrink. And if I remember correctly, what's the length I cut it at? 9, yeah, 9 centimeters. So I usually use the markers on the table to cut it. I'll go for 9 centimeters. Then carbon plate, heat shrink, and then we heat it up. Let me grab my hot air and remove need to remove the tip, because when you heat shrink, it's easier to do it without the tip or with a massive tip. I'll use a massive tip. Good. And I'll go for 250. I'll show you this way, actually. You'll see that it takes a while because this is super thick stuff. Try to do it in a way that you can. You don't really have to worry about the LiPo getting hot and suffering for it, because if the heat shrink's not shrinking, then the heat shrink is absorbing the heat and it's not heating the pack. So I'm just doing it first so that I'm doing both sides. Then I'll do the front and back, top and bottom. and then I'll come and complete. I could probably do it hotter, but I could definitely do it with more airflow though. Let me set that to max airflow. It's on 50%. There we go. Trying to show you as much as I can. But yeah, that's this. This is the Isolatec heat shrink. It's really good, very, very thick, quite heavy. There's about 8 grams of heat shrink on those LiPos, but it takes a while to get tightened. There we go. All good. And yeah, the LiPo is a bit hot, but that's just the heat shrink. 1 repaired, 3 more to go on those cells. It's time to go grab yourself a coffee and start watching a show on the side, because it's going to be very boring. What's the size before heating? It's 50 diameter or 50 wide. That's when you buy them from them, you buy the 50 mils. It's good shit. Okay, let's see if we can get this one done faster. We're not trying to speedrun this because it's LiPos. You need to be careful and not be stupid. But let's try to be efficient. Let's see if we can be efficient. Learn from doing it. I've done it a few times, but when only a few times, and the more you do something, the better at it you get. Let's check which cell is dead. Have some shiny solder here. It's truly and well welded to the mat. Yep. That's nice, shiny. I'll check directly on the balance lead. So that's not this one. So once again, it's going to be cell 6, which is low. I'll check, but I'm pretty sure it is. It's not dead. Yeah. So we'll check the internal resistance on it once we move it. It's going to be the exact same operation because it is the same cell. So we'll do the same thing. And move and remove. Oh yeah, 70 mils. Yeah, I'm surprised you can actually get it shrunk enough. It's only 2:1. I guess 2:1 is still quite a bit, but yeah, it's impressive. My alcohol bottle here, my pry tool here. Let me unstick the back too. And when I fly them, I'll make sure I'll kind of keep in mind, like I'll watch them more closely, the ones I repaired versus the ones I haven't. See if they lose the cell, see if they have issues. It's going to be the same thing, so I want to keep as much tab as I can here, but I want to leave a tiny bit of tab so I can measure internal resistance for you guys and for myself, for my own curiosity. So I'll leave a tiny bit of tab in the corner. Surprised I haven't made sparks yet with my pliers. Happens every once in a while. Keeps stuff interesting. Now we need to cut that. Get done. And desolder. Let's put some lidded. And let's try not to burn ourselves with the hot melted solder, if you don't mind. Yay! Okay, let's check the internal resistance. So we saw that the normal values are 1.5, 1.6. Let's see what we get here. Come on. Is it not measuring here? Yeah. So if we can get a good measurement, please. We need to, I think there's flux on the... I can't think it's going to be 34 though. It's going to be a measurement error. It's always hard to get the pliers, the way it works. You need good contact on both sides of the clamps. So they both need to touch metal, not just one. Or you get bad reading. I mean, we are consistently getting the 60s, which would be extremely surprising to me, but could be. 34, well, yeah, maybe it is 34, maybe it's hard to measure. I will need to solder something to the pin. Let's see if I can get the pin, the thing clamped a bit more and in a way that gets good contact with scratching the surface. Could give us better results. Let's clean it up with that IPA as well. Clean up the flux possibly. Get some good readings. Yeah, no, it's consistently 35, yeah, so it's completely fucked. Well, It's fucked. That's what we're replacing it. All right, this needs to figure out which is plus, which is minus. Okay, so this is plus. I'm always going to be double checking just in case. That should be negative number. There we are. Okay. So let's prepare the tabs. Here I don't need much because I'm going to be soldering the big tabs. So I'm going to cut the back part of it. Ah, there we go. Sparks. You wanted sparks? You got sparks. That's when I'm not careful. Always get very surprised when I make sparks. Yay for sparks. Oh, shit. I need to increase the... Oh, the fan died. That's why. Give me a second. I'll be back. On the top-down camera, I bought a fan that's supposed to cool it down. That's on battery, and the battery died. So I'm going to go back to my previous powered fan system, ghetto fan system for the camera. Hopefully, at least one of you was looking where you get spark, so we don't get spark for no reason. Otherwise, you can always watch the replay. Sparks, fun, always fun. Now we get proper cooling. Let's turn that back on. Yay, we have signal again. Let's try to not make more sparks. So I was trying to cut out. So my mistake here, so you don't make the same mistake, is I was going at it from this side. So while I was touching this, and I managed to touch both and sparks. But if I come from this side, then there's no danger. There's no danger at all. I can go and cut the thing. There we go. Now we have a nice tab for soldering our positive lead. This one I just need to, so let's see how I'm going to do this. I like the idea of having this come over and can do a nice solder joint, so I'll be doing that. I'll fold this a bit back and I'll put it in place and solder it in place with some of the yeah, that's going to come here like this nicely. I'm going to put a bunch of solder into this. And it's going to be perfect. Yeah, liking this. So I can just put some solder on this for our positive lead. I'm going to put a bunch here. Looks very clean, so it should apply fairly well. There we go, nice blob. Want to go quick, so because we don't want to go and heat the pouch too much. That's why I'm trying to be quick. And here we get a nice fit. And here I'm going to be putting some flux in there. And let me tighten it so you can see. There's flux in here and solder it nice and good. Let me spread that flux around so it's here. I want it here as well on top of the other piece of metal. There we go, bunch of flux. And let's come with our iron and give it a good lick of solder. Shit, it's going down there. It's not doing the job like I wanted. It's kind of starting to do it. There's a blob of solder down there that I don't want. Let's see if I can gather it. Ish. Good. Now let's finish this by adding a bit more flux and dumping a bunch of solder. There we go. Now it's good. Nicely connected. Great. Awesome. Oh, now I just need to make sure I get this right in the right position this time. Oh, good. Have a stray strand. Yeah, putting back the stray strand and put some flux, normal flux, over this. Let's see if I can quickly clean up here, down there. Don't know how much I can, but and yep, solder this back on. So that's a mistake using these pliers. I don't want to make the same mistake again. And yeah, so let's put some more fresh solder on this. Shit, came out. Don't want to stay too long on this. There we go, nice and clear. Do we still have connection on the balance lead? We do. Yep, let's check. Yeah, 6 cells. Nice. All right, this time I've routed it correctly. I'll put a cap on like it was before to protect this cable from rubbing onto the other joint. Do a bit of cleaning. And captain. Let's shorten it a bit. Okay, some captain on there. And close this shit up. All right. Acetate. This time I'll take enough to do a full circle, I think. Should be. So hopefully this will make you, if you're watching now or and didn't know you could repair your LiPos, or you're watching later, maybe, hopefully, this will make you fear your LiPos a bit less. They're not that deep, bro. No, yeah, it's good to be have a healthy respect for LiPos, but you definitely do not need to fear them. That's not aligned. No. Let me align this back. There's a bit of crud here. Let's try to close the LiPo well and compact. There we go. And let's do the same at the back with Captain like we did before. Hey, Liviu. Yeah, exactly. Don't fear the LiPos until they start smelling funny. Is generally a good advice. All right, and one. Let me remove that thing actually on the other side, because it's supposedly can cause issues. So, all right, let's pack this up in heat shrink, and we'll move on to the last one, and then we have a balance lead to fix, which is going to be. I'll try to demo all the tools you can use to fix those, because it's kind of a perfect example for that. But yeah, it's also one of the reasons I'm doing this video as well, on top of me needing to actually repair my LiPos to fly, is so I can have a reference. I can point people at the stream if they want to do repairs on their LiPos. Well, you say that if I smell candy. Well, the other day I was heating up the flux you left on the board you sent me, and it smelled like candy, so should I be scared? I wonder what your flux is that smells like that. What is your flux that smells like candy? I bet it's some old-timey, true and tested reference that you can get if you, I don't know. Oh yeah, there's 2 more to do after that, I forgot. Oh well, it has to be done. I'll go up to 300 because it's taking too long for the heat shrink. There you go. Hey, Spawny. I mean, you haven't missed much because we're gonna do it again two more times. Oh yeah, MG Chemicals makes good smelling shit. I mean, they make good shit in general, But the stuff smells good. The super wick does. One more pack and 2 to go. We're doing this in decent time. Let's see if I can make one without either burning myself or making a spark. That'd be nice. Just a second. Let's go again. So yeah, you missed the spark, but I think most people were doing their own things when the spark happened, so it was a very discreet spark. But I was 100% me being stupid, being careless. Well, it's just a spark. And you missed some, I'll try to do another one on this cell as well, some internal resistance testing to check if the cells are actually really fucked, and they are. Let's see which cell is the dead one this time. Well, actually, I can just check. I know cell 6 is the positive one, so. So yeah, this one has a dead cell 6, likely. So it's going to be the same one again. I'm just going to confirm. Always confirm. Don't trust but verify, as they say. Yeah, it is indeed 0 volts. So let's do this again. What's the time, Doctor? It is 22:37, so 10:37. Why that? Why do you ask? It's battery repair time. Could do that, could say that too. Okay. So once again, same cell died again. Most of my tattoos die exactly the same way. Which is weird. I'm not sure how I can explain this, because I fly with the LiPos vertical with a carbon plate on top. Why would this side be favored? I don't know. Time of the Dead. It's not Time of the Dead. I'm not gonna die. I'm not a zombie hunter either. Let me remove this as well. Our patient is 5/5 alive, 1/5 dead. IPA, IPA. Do your thing, IPA. See, we'll see if we can compact this LiPo. Once again, let's try to cut this without making sparks. And we can try to leave a bit more on the thing so we can measure internal resistance. There we go. I mean, it's dead, so I'm guessing we're going to get the same kind of internal resistance as before. So that's not one of the interesting ones. We'll still measure it for fun, but we're not going to get a very interesting value because it's completely dead, so it's going to be a lot of ohms, milliohms. So I'm adding about a bunch of leaded solder to the joint to make it melt better. Then I will remove it. There we go. Let's check internal IR. With the IR meter. And we should see a super high value because it's dead. 44. It's not as dead as others, but yeah, 44 milliohms. The normal value of those packs is about 1.5, 1.6. I will recall. I will remind the public. So yeah, it's dead. Let's see if we can compress this pack a bit with our trusty box. Is it compressed? Maybe. I don't have a 2,000-pound press, so I'll do without. Next cell. This, let's see which is. So yes, for you, Spawny, if you haven't seen the normal internal resistance of those. If I get good contact, should be 1.6 milliohms. Let's put that away. Which is plus, which is minus? This is plus. You finished soldering and cleaned everything up just to find out. What are you working on that you're having to redo? What's the thing you're talking about? Just fixing a quad. So this will go here. Alright, so I don't have a nice way to put this one on. I'm gonna have to do the same as before, but I'm gonna cut the tab very shortish. So that's when I made the mistake last time, so I'm not gonna make it again, and I'm gonna cut cleanly. Goodbye. And I'm gonna be putting this here. So I need to put some solder on here and below here. I'm gonna cut it a bit more actually. I don't need a ton. And I need to put some solder on the other one as well. Can I? I'll try to, I don't want to have to melt it, but I'll remove this bit of solder. because it's on the back. Okay, here should be good enough if I put some solder on the back of this tab, and on top of this one should be okay. Let's solder this up. Couldn't get it to adhere. Let's do it again, clean it up. Maybe I just need to put on some more of that flux. Let's try putting a lot, see if it helps, and hold my breath because it's probably not very good for me. Yeah, that's probably good enough. Though I do want to have some of it in the middle, so let me do it again. Clean it up. GPS to GPS mate to FC. Oh, GPS mate is the helper thing that gives you lock without the battery or something. Yeah. I don't really use GPS, and by don't really use GPS, I have one in my drawer for maybe if I need one someday, and I never needed one, so I can't help you a lot here. Okay, it's going to be good enough. There's plenty of solder on there. Now we need to put some here. I can't get it to stick on this face. Oh well, there seems to be enough there. Maybe not. Let's see if I can get some to stick. Okay, I think that should be good enough. Okay, and we need some on the other face of this. Okay, that went well. Plenty of solder here. Now we just need some regular flux. Some cleaning up. We just need to meld this together. Should be easy enough. Yeah, I think that's melted. Let's put some more here. Yeah, I think we're all good. Yep. You can always check if we have the right voltage, total voltage here. Oh no, we don't, because I haven't connected this yet. Let me connect this. So this needs some regular flux. And tweezers. There we go. Nice. And now we should check. We have 22.9, which is good. And this is all 6 cells. Nice. Hey, bad cactus. You're impressed? I get that much on there. If you're talking about being able to put garbage on my desk all the time, then yeah, I'm always impressed how much I can put garbage on my desk in 2 seconds and I can't find my around. I'm not sure that's what you meant, but that is a fact. I am very good at putting, invading my own desk. So yeah, just need to do the usual packaging, some Kapton. I mean, not even sure why I'm putting Kapton here. It doesn't not doing anything. There's some still. I'll just fold it back and be done with it. Save some time. Have to save some time somewhere. Oh, so the tin on the nickel LiPo, that's the secret. That's flux designed for this. If you don't have this, you just can't. It just doesn't work, it doesn't stick. So that's the secret. And the first time I tried, I didn't know. And that was very difficult. So yeah, you get the €2, you search like aluminum flux for soldering or something like that on AliExpress, or you can poke me and I'll send you a link. And it's super cheap, and you need it for that specific job, or soldering lithium-ion cells as well. If you want to make if you don't have a spot welder and you want to make a Lion pack, there is a bunch of arguments being made around whether it degrades the pack. It's possible that it does. I get a feeling that if you're very good at your soldering job, you come in hot, fast, and quick on your 18650 or 21700, then you'll be fine. And the secret to coming quick, sorry, don't take that out of context, please. The secret to soldering quick on those packs is to have that flux. So yeah, get some. Kapton. Where did I put my Kapton? Here, under my nice. Okay. What time is it? Yeah, 1 hour left. Should be able to finish everything by the end of the stream. I even have a bonus content if we have finished early. Yeah, FP packs don't last forever, especially lithium-ion packs. So how much are you going to fly those? Like, you're going to fly them maybe let's say you do a lot of long range and you fly them twice per weekend, and you do like 10 weekends at the mountain in a year. It's like 20 cycles a year. Yeah, I can't. I don't think you're gonna be seeing the end of the pack anyway. So unless there's something weird that happens to a cell where it degrades and falls quick and stuff like that, I think mostly fine. I have done soldering on lithium ion even without the flux. It works. With that flux, it's trivial. Looking for the heat shrink. 9 centimeters. Carbon. Oops. Heat shrink. And hot air. Clean that up. It's not all dirty. Okay. And then you get the heat shrink view where we dangle the thing. Trying to make it as visible for your, it's the third I'm doing, so you're pretty used to it by now. There you go. There we go. And one more. One last one. One last time. Gonna celebrate. No, that's one more time. Okay. Oh well. I'm guessing it's still the same that's dead here. Let's check. Back 6. Yeah, it is. Surprise, surprise. Said nobody. The whole thing is a bit bowed, but yeah. I don't know why I tend to crush more on cell 1. Maybe it's a byproduct of me always turning left or something. I haven't checked actually in my latest edit whether I was turning left all the time or not. I always tell people when I turn left, because it's something that you can work on. But I didn't check whether I did as well. I know I do turn mostly left, but not always. I do try at least to mix it up. And I'm happy it's the last one. It's not extremely fun to do. I think normally I would just throw an audiobook and do it while getting entertained. But while I'm at it, I could say, oh yeah, you've seen enough on the stream, I'll do them off stream, but I don't have time because I'm leaving tomorrow afternoon. And then I'm not back for a while, so it needs to be done. So I'm sorry, apologizing for the repetitive content. It's not what I mean, I guess electronics repair have some element of repetitivity, but I found doing a lot of repairs recently that there's very often something different about them. While changing LiPo cells, there's very, very little that changes, especially when it's always cell 1. We could have, like, throw us a bone, like, hey, let's do cell 6, cell 1, yeah. But no, it's always cell 6. Yeah, there's some amount of, someone could say it's just not worth the time, and I would not fault them for not wanting to spend the time fixing a LiPo. So this one, we'll see I'm very curious about this one specifically because I'm going to leave enough tab so we can see the resistance, because this one isn't damaged by a lot. It's just, I just know the LiPo only lasted 2 minutes because of the dead cell, but I'm very curious to see what's what. Yeah, you're right, Backcactus. That's the main reason I decided, because it was a choice to do it on stream at all, just because I've been requested. There's something people have requested quite a bit. Like, next time you fix LiPos, do it on stream, because it's a good resource to point people to, so you can see it's not very difficult. I would say you kind of need to be comfortable with soldering. But if you're comfortable with soldering, then the rest is just not very different to what you just like what you usually do. You just cut stuff and put stuff together and use a multimeter to know what's positive and what's negative and solder it back up. So yeah, it's good that people know that it can be done. I mean, you have to weigh your comfort versus your reward. Here, the reward is like, I don't know how much those are if you buy them brand new, but about 40 quid, 40 euros, something. Still used to saying quid. So yeah, the reward is not negligible. Like, I've just saved 4 tonight, so that's 160 euros. I don't want to start breaking my box. Yeah, I don't think it's high stakes if you understand what they do, how they work. They will, like, even if you get a spark like I did. Oh, no, oh, sure, sorry. I thought I had pierced the cell, but it was just a piece of solder. That would have been bad. I would have had to, it would have become a donut. You're traumatized, Pony. What happened? So yeah, I wanted to measure this one. Let's measure it. and I get a good spot to put my clamp on this one. Yeah, so yeah, 6 milliohms. So that's about 4 times as much as a normal cell. So yeah, it's dead. It is dead. So many dead cells. You poked. Well, that's the thing. You don't poke back. That's how you break them. So the secret is to not poke. What happened? How did you poke a 5,000 map pack? How does that happen? How does one accidentally poke a pack? Poke a pack? Which one is positive? This one is positive. I am positive. Let's make it a bit smaller. Okay, gonna go thusly. Yeah, that's good. I'm gonna be able to solder that directly. That's good. That's what I prefer. And this, I just need to put some solder on. Tuk, tuk, tuk. Looks. I got a breath full of this stupid flux. And this one doesn't smell good. Oh, yeah, I should be doing it under my hood, my thing, but yeah, I'm not at the moment. I'm not next to it, and that is going to remain this way, because otherwise you guys won't be able to see. You know, content before health, as nobody says, ever. Let's see if we can get some flux in here. In here. I want to hold this. Let's grab a plan. Can I hold this? Yes, I can. Okay, nice and connected. Now I just need some flux. And I just need to get this well soldered. Yeah, so I'm starting to understand how this flux works. And you don't really have to, you can leave your iron a bit on it, and it doesn't, still makes the surface active, so it's not too bad. Was an airsoft battery stuck in a battery box, and I tried to push it out with a hex key. Yeah, poke, fire, something bad. Well, it looks like you survived. That's the good part. And generally, surviving is a good start. Flux, flux, flux. Done. We are done. Let's check. 22.9. And this all cells good. Setting time. All right, now we just have one thing left, which is a balance lead repair, which will involve some depinning, some repinning, some splicing, and a lot of other excitements. No, absolutely no other excitements. It's just going to be those three. So, but hopefully you love repinning stuff I do all the time for the stacks. Right, now a bit of Captain at the back. A lot of flames and smoke, but see. Oh yeah, you had it. It happened inside, and you managed to go outside. That's good. Yeah, you need to respect the batteries to understand them. They are humans after all. So respect your lipos, and they will respect you or something. But yeah, if you're careful, like I am with those packs, you do go slow and take care. There's really just only 3.8 volts in each of them. That's not very dangerous. Okay, heat shrink. Okay. Last round of heat shrink demonstration. Not that you'll need it now. It's good to have on the replay though, to show people that it's fine if it takes time to heat shrink on those super thick heat shrinks. It's okay if it's long. You're not gonna kill the battery. wonder if I could just hit a corner and do two faces at once. Maybe that's a nice improvement I should do on my wrapping flow. But that's not as if we're gonna spend a lot of time doing it. And done. This is the fourth one, and last one is that. So yeah, those broke in a crash. They broke inside of this, so I don't know how they collided something. But, and then when I went to unplug, I make them touch together, and it sparked inside my finger, and it hurt. And as I was trying to unplug the LiPo and remove the thing, I got the two of them to contact again. So they kind of fused together, and the wire acted as a fuse. And that's usually what happens if you short balance wires. They are way too small to withstand all the amps from the packs, so they just melt. So you can see some nicely melted and oxidized copper. So this wire at some point inside has nothing until a certain distance. So I'm going to have to cut it and add a new one. The two that are burnt, I'm going to cut as well and splice. And we happen to have a LiPo lead here, so we're going to use that. I have a bunch that I can also repin them, but we need to deepin the first 4, and then those 3 we're going to splice. So I just need to deepin that. So the way I deepin those is by using one of my least favorite tweezers, because they kind of have to break. Bad thing, nice carbon sheets, by the way. You heard about POM battery plates versus carbon. We do a lot and lots of testing of various ways to protect LiPos, and some people have a big, massive TPU top, and it's super heavy. Usually it's like 40 grams, so it's almost like, some people have them really massive, so it's like putting an action cam on your drone, which I find ludicrous. I do carbon plate, and a bunch of us have switched to carbon plate. Some of the friends were doing aluminum, so they bought some sheet metal aluminum and they bent it over, but it actually doesn't prevent deformation. So in the end, it wasn't great. Some of my friends use a TPU that they move from battery to battery that has a carbon plate inside. So they just have one carbon plate for all their LiPos, basically. So that works well. It's a bit heavier, but it doesn't require cutting more carbon. By the way, you can cut this with scissors. It's 1 millimeter carbon. I used to do it with scissors. Now I do it with the CNC because I'm not, sometimes cutting with scissors is very annoying. But I haven't heard about POM battery plates, but I would argue that it's literally nothing that compares to carbon. There's a reason we use carbon for our frames. It's light, it doesn't shatter, it doesn't puncture, and it's super stiff, so any impact is going to be spread. But you can see my LiPos tend to bulge out because they get hit and they just get damaged. I have a friend who's doing, and that's probably something I'm going to be doing next time I do it, full carbon armor. So it has carbon plates all over. And what I want to do is have the top plate overhang a bit so it can rest on the 2 side carbon plates, and they rest on the bottom carbon plate so that any shock gets transferred to the side and can't compress it. That will be the ultimate form. I'll have to see if I see some problems with it, basically. But that's my next step. But this is already really good. Like, I'm killing batteries way less often than I used to do before I started protecting them. And we used to see a lot of LiPo fires. Every session had a LiPo fire at some point from someone. Now we barely see any. I can't remember last time we saw a LiPo fire, actually. It's very rare. So yeah, you absolutely want to protect them. I think nothing compares to carbon in terms of rigidity, to weight. I mean, obviously, if you put a steel plate, it would work too, and you would tank your quad. You say it's supposed to be this, the right rigidity and impact resistance on POM, but it's not as rigid as carbon. It's plastic. It's not as rigid as carbon. So what could it make better than carbon? Let me weigh this for you, so we can see if that's a relevant argument, because that would be the main one I can think of. I haven't weighed them, so I might as well. So 3.6. Can you get anything close to that kind of safety with 3.6 grams on POM? Be very surprised. Like I had, when I posted a video about those carbon plates, a short, I had KinXD comment that he uses 1mm PETG. And sure, maybe it works and it helps. That's very possible. But I can't see how it can be as good as carbon. And it's not like it's not like it's that expensive. So, but yeah, pigmented heavier, I think it's going to be like, the pigment is probably less than 5%. So I don't think that's going to affect the result too much. So yeah, deepening those is much more annoying than deepening the usual stuff I do. So the way I do it, I take some pliers that don't mind bending too much, the cheaper ones, and I push the thing down all the way, and now I can pull it back. And if I want to put, now the tab that retains the pin is folded back, so it won't bind anymore. So if I want to plug it back in, I actually did this time, but usually it's very weak. So I then take a tweezers, and I'll see if I can show you, and I put my, I take my knife, put it inside the tab and pull the tab back up. You can see it here. And then it will click nice and well. But in this case, it doesn't matter because I'm not reusing those, but yeah. 20% pigment, that's a lot. But like, let's say pigment is 50% more dense than your 20%. That's exaggerating. I don't think pigment is 50% more dense, but it could be, I don't know, much. Then your 20% pigment and your 20% of 50%. So you're adding 10% weight versus pure POM. That's back of the envelope, obviously, but back of the napkin math. But those are annoying to remove this time. There we go. This one. So yeah, only 5% more weight. That's not gonna be the end of the thing that makes the difference. Some Delrin. I don't remember what POM stands for. POM. I know it's what the brand name is, Delrin. That's a very usual, common machining plastic. So now the thing I want to do when I swap this to a new one is I want to remove this one and put it in the new housing immediately, so I don't run the risk of shorting them. If I were to pull two of them and they touch, that would make sparks. They would probably not fuse. The spark usually pushes them apart so they don't get to fuse and short and melt the wire. But why take the risk? So I've lifted the tab and I can put them back in. Also, if you do it as you go, you don't mess up the sequence, which is something we're going to have to be careful of when we do the soldering, the sequence. You have to always check, because sometimes they come out of the LiPo in a certain order, but they might be mixed up under the hood, and you end up, oh, spark. Man, I get super surprised every time I make a spark. But it's not dangerous, like it's just a spark. But it does, what did I put? I don't know what fell down. It does make me jump. Darren, how American are you? I do watch a lot of YouTube, and a lot of crafter YouTube is American. To my greatest demise, a lot of CNC content is in Imperial, which is not fun because I don't really talk inches per minute. But, you know, I watch a lot of things. And there's a lot of American content online. Let's try to not make... I don't even realize how I don't know how I make a spark. How I managed to make a spark. What did I short with what? It's a good question. Let's try not to put a spark in my finger again. That would be nice. Come on. Oh, what? Oh, wait. How did I make a spark? Oh, I know. That's funny. So, let me show you why I'm making so many sparks. So I told you a wire acted as a fuse. That's this wire. That's why it's melted. But on this side, it's still melted with the other guy. So this is actually live to this wire. So that will make a spark if I touch it with a... So yeah, I should probably cut it so I don't make more sparks. Sparks. Surprise. Shocks you. So you have a 5x455. So that's 5 by... Yeah, that's about the same area. So it's only a third of a gram. That's very, very light. I would not... So basically, is 3 grams... Do you pick 3 grams or carbon? And on a 5-inch, I'll take the 3 grams. On something where weight is critical, that is definitely arguable. I mean, but Cactus, if I don't show you that it's harmless, then you don't get to learn that it's harmless. So yeah, I do it again. And I'll do it again in a heartbeat. But yeah, now it didn't spark because I cut the thing. I mean, sparks do burn you if your finger's in it, but otherwise they will usually push the thing apart. But I did get a bit of a surprise when I saw the wire melt and Sudoku itself to save the LiPo. I'm gonna use push it in. There you go. And now we just want to cut those wires and solder them. I'll start. So I hate splicing. I find splicing very untidy. But here, don't really have a choice. The wires are gone. So I'm gonna have to splice. So this, but the whole thing is super rigid. How much did it melt? I don't know. Did it wick some solder in? It's super weird. It's very rigid. So maybe it sucked some solder when it went super hot. Oh no, there shouldn't be any solder anyway. So I don't know. Let's see if it's if I can get a reading of it. So that's it's the middle one. So it should read something here. It's hard to hit the center of the wire. Do I get a good contact? Probably should have tested whether the LiPo is still... Oh yeah, still 3.7 volts. That's good. I should test whether the LiPo is still alive, but I'm pretty sure it is. Yeah, 22 volts. There's no dead cell. So this needs to go to this. So we need to leave some room for the splice. I'm never doing like awesome splice NASA twisted crazy splices, just because you need a lot of length of wire to do it, and it takes longer, it's fiddly, and we are not, it's a balance cable, doesn't need to be fancy. So I'm gonna do a dumb splice where you just put solder on both and touch them off. I am going to see. It is rigid. So maybe I think what happened is the copper from the wire actually melted and it fused together, it sintered together. That's crazy. Yeah, they do bring the amps, those crazy LiPos. Have some heat shrink. Let me put some solder on both sides. Huh. It doesn't want to take solder. Put some flux, see if it will. It's weird. It doesn't want to take solder. It does take enough that I will be able to weld, to like solder together, but it's weird, it doesn't want to take the solder. Let's see if we can do this quick and dirty. Where did I put the small piece of heat shrink? I don't know. Let's see if we can put a bit more solder on here. So I did manage to put a bit of solder on the. Yeah, so it's attached now. It's not very pretty because that wire melted thingy doesn't really want to stick, but it's more than good enough for the balance lead. And if I ever find that there is an issue with that cell on the meter, then I will simply redo the link. I can always open the LiPo and change the wire at the base, but shouldn't have to do that. Okay, let's do another one. Oh, I managed to do the wrong one. So that's fine. I can just depin and repin, change the pinning. Let me heat shrink it just so I don't have to do it, so it doesn't slide. So yeah, it was the second one. So let's dip in. So if you're not sure what wire goes where, you can always check voltages. But here I know where it comes from the other plug, so I can just follow the instructions. So this guy and this guy. Let's cut it. And let's cut this to the right length. I can also cut this one. There's no current in it. There's no voltage on it, so I can just... Try to not forget about the heat shrink, because otherwise you have to undo it and do it again, which sucks. Right. Let's see if I can do it without having to put on more flux. So if I'm quick enough. Yeah, good enough. Just line them up and touch your iron, and it just goes together and melts together, and you're done. I'm not going to heat it up because I'm going to melt the one next to it if I do that. Last one standing. Going to put a bit more of a blob on one of them so I can more easily join them. But other than that, it's as easy as that. There you go. Not pretty, but it's not coming apart anytime soon. And now we check. There we go, 6 cells. I'm going to be able to put that one on storage. And here we go. We fixed that many batteries. Cool. I'm going to be able to fly. Well, I still have a bunch of batteries, but 5 or 6 of them kind of really limited my stock. So yeah, this stream wasn't, there was absolutely no troubleshooting this time. I was purely doing it and showing you all how to do it. Hopefully it's gonna be useful for one of you. Hopefully it shows you that LiPos aren't that crazy, aren't that dangerous. You are not going to melt down your house if you take a look at them weird. You have to respect them. You have to be careful when you do stuff. Take your time, and it's all fine. And you can save a ton of money by not throwing them away. What I do, so one thing I forgot to mention, when you repair a LiPo, you want to use cells from the same exact LiPo. You want similar, I mean, you can probably mix and match if they are very similar internal resistances and they have the same capacity, but you're never sure about capacity because they all, like all companies measure them their own way. It's probably somewhat accurate, but maybe not. And it's maybe not the same chemistry, so it might not have the same discharge rate. So just save up one kind of battery, and when you have enough of them to fix, just to do the batch like I did. And there we go. So, I mean, in terms of, we spent 2.5 hours fixing 5 batteries. So it's about 40 euros for half an hour, for 80 euros an hour, if you want to think that way. I don't know. It's not too bad. I don't do any of what I do for the money anyway, because, you know, I spend 3 or 5 or 10 hours on a repair and I give it away pretty much. So, but it's good to know that it's somewhat worth it. Hopefully you all enjoyed. I will not see you next week. I will not see you the week after that. So there's going to be 2 weeks without any stream. Then I'll let you know when I'm back. I might start doing something a bit different. Might start doing streams a bit less on a regular schedule and more when I want to be repairing stuff. I'll turn on the stream. We'll see. I think most people have mostly moved like I'm not getting a lot of views on the stream, which is completely fair because it has some amount of repetitivity, and once you've seen some of the things, you not want to see it again. So maybe I'll just stop doing streams for a while, or do it when I just want to repair something I'll check and share with whoever is around. And then in a few months, I'll start doing a few of them again. But yeah, keep it like, let the interest build up again, and people will want maybe to see other things. Or if someone asks me something specific, they want to see a specific repair, or they have a very weird problem and they want me to have a look at it, maybe I can send it to me. You can do it on stream, but might not do it on the regular as much. It's been a very fun anyway to do this stream. I still have, I'm not closing the window on streams anyway, so I'm still going to be around. I'm going to be working on videos as well, which I have in the background, but not as much, especially since we're planning the event in 2 weeks, which has taken a bunch of my time. But there will be videos again at some point, I promise. All right, have a good evening, everyone. Thanks again very much for tuning in and keeping me company while I fix my hardware for my trip. And I will see you next time. Bye.